Hello everyone. So I'm going to explain you the linked list program. I'm going to dry run and show the algorithm of the linked list. So as you all know, linked list is a concept which does not have the memory allocation which is in contiguous format. It will have the memory location wherever it is available, but all the nodes or all the elements that are being inserted into the list will be bound together with the help of the address part of the node. So before we enter into the concept of the linked list, I'll explain you how a node will look like. So this is how a node will be like this in a linked list. You will have a node which contains two parts. One part will be the data part and the other part will be the link part, or you can also call it as the address part. Okay, so data part will have the element that is present and link part will have the address of the next node. Now suppose if 100 is the address of the next node, now suppose this is 1000, the address of this particular node is 1000, and if I am creating a next node, now this will be the next node which contains address of this node as 100. So we are linking this particular node with this through the help of this 100. And this node contains two parts which contains the data part and the address part. This will be again joined with another node which contains the data part and the link part. So like this it goes on continuing, and the binding of the nodes will be performed only through these addresses. Okay, now these arrows and these physical representation of the linking is performed only for your understanding and for our identification. That's it. You are not going to see this in the memory location when we actually discuss with the or actually declare with the linked list. Okay, so now let's enter into the program and see how the program is getting executed. Now here in the class linked list, in the private access specifier, I am taking a structure which contains a data part and a link part. So when you are creating the struct node, what is happening? The name of the structure that I am creating is of type node. Okay, so the name of the structure is node. As you have the class name with linked list, you have the name of the structure with node. Okay, so here in the node, what is having? You have the data part and the link part. Now if you see here, when you create a node, you have the data part and the link part. To create this particular node, we are using a structure. Clear? So here we are creating the structure of node type, and you have int data and node of star link. Star link is the part or a pointer that is going to point to the memory location of a particular node. Okay, and we are creating an object of this particular structure by P. So here P will be an important variable that stores the address of the structure that you have created, that stores the address of the node that you have created. Okay, so P plays an important role in your program of linked list. Clear? Now here in the public we have the functions that we have to create. You have the linked list constructor that is used for creating the memory space for the data members that you have created. Void append int number, a type of the variable that you are going to pass as integer. Void add at the beginning, that is of integer type again. Void add after, here you have to pass the location, since it is add after which location you want the number to be added. Okay, then you have the void display. You have to display the elements whatever are being added in the linked list. Okay, even after adding at the beginning, even after adding at the end, even after adding after a particular location, anywhere, anytime you want to display the elements, you can use the display function. Okay, int count. You have to count the total number of elements that are present in the linked list. Okay, then you have to go with the delete function which deletes the element, and here you are passing the parameter of number which will delete the number that you want to delete. And here you can see the destructor. Now this is a tilde symbol which is used for destructing the memory that is being allocated by using the constructor. So in the class we have already discussed, whatever memory you are allocating through the constructor, you have to deallocate that particular memory through a destructor only. Okay, so here a constructor plus a destructor should be present, and whatever the memory you are allocating through the new operator should be deleted by using the delete operator. So when you create a new node, you will create it through this new operator, and the memory that you are being created through that particular new operator should be deleted through the delete operator. The memory that you are allocating through the constructor should be destroyed by using the destructor. So okay, so this is an important point that you have to remember. Next, how we are initializing the data members of the class constructor. So here linked list is scope resolution operator linked list, p is equal to null. So we are initializing the pointer p variable as null. So what is happening here? Since you don't have any address of any node present, so p is being initialized as null. Means you don't have any nodes that are still created. Clear? Next, void linked list append. Now before we actually enter into the append program, we'll just get into the, see how many pages the program of linked list is. 1, 2, then you have 3, 4, and this is 5 and 6. So in the 6th page you can see the main function here. So linked list L is the object that you are creating for the linked list class, and L dot append. When you create this append, when you call this append function, it should add to the already existing list. That means append function will add to the last node of the existing list. So I am adding 5 elements to the append function. So we'll just get into the append function and see what is happening there. So here is append function. Parameter number is the number or item that we have passed through this particular called function. Node star temp star r. Star temp is the variable that will be used for storing the link part. That means whatever link part is created here, that will be used for storing the address of the link variable. Star r is to create a new node if there is no node that is already created. Got my point? Append is used to add to the already existing nodes. If there is no node that is created, you have to first create the node through the r, pointer r, then add a new list of elements to the list. Now here see the condition. If list is empty, first create the node. So how you have to create if p is equal to null? Because since p is initialized after the constructor is being fired out, p is equal to null. So when p is null, if p is equal to null, then what should happen? Temp is equal to new node. That means we are creating a new node if it is null. If temp is equal to new node, that means a new node will be created. Now I am showing you how the node is getting created. This is a node that will be created as soon as you call this temp is equal to new node. Okay, so temp of data. What is this temp arrow data? Since you have used structures here, you have to call a structure object by using an arrow. When you create an object for the class, you will call the object data member by a dot. Okay, so structures will be using arrow to call that particular object data members. In classes, you will be using a dot operator like s dot pop, s dot. We have seen so many programs till now. Okay, so that will be the difference. When you are using a structure, the members will be called by using an arrow. So here temp of data is equal to number. Whatever number you are passing, that will be stored here in the structure of node. Okay, so this data will be initialized with the number that you are passing to the node. So here in the node, you will create two parts. One will be the data part and other one will be the link part. So this is the node that is getting created, and the node will have the number, whatever number you are passing. And since this is the first node, you will have the link part as null. So again p will be null here, and p will be pointing towards this particular node. Clear? Else, if suppose this is not the first node, if already nodes are existing, go to the last node. When will you find the last node? When temp is equal to p. That means when temp value is equal to p. What is p value? it will be null, because always P will point to the last node. Okay, so it will reach to the next node whatever is being present at that particular last node's address. Clear? So here we are using temp is equal to P and checking a condition while temp of link is not is equal to null. If temp of link is equal to null, what will happen? It will be the last node, isn't it? So when it is not equal to null, you have to move to the last node. That means how you have to move? Temp of link. Now if you see here, I already said node star link will store the address of the next node. So through this link you have to traverse to the next node automatically. So temp is equal to temp of link. So as you move on to the next node, immediately the next node's address will be stored into the temp of link, which will be initialized with the temp. So here while condition is checked until and unless you have not null, then you will go on with the traversal of the link. Once you reach this null, once you reach the null, what will happen? This particular statement does not get executed. You will immediately come back to this particular statement. So once you reach to null, it will be the last node. Okay, so add a node at the end. So what you have to do now, if suppose I have added some elements. Now here I am just showing you if there are some elements present. 10 is there, 100 is the node, then 20 is there, 200 is the node address, then 30 is there, and I have null here. Okay, so this is the first node, this is the second node, and this is the third node. So what happens now? Now since temp of link is null, that means if it reaches the last node, that is the third node, then you have to add a node after this third node. So what you have to do? You have to add a new node here. That node should contain the new element that is to be added, and the address of the new node should be null, because you are going to add the address of the new node into this particular node, that is the third node. So what you have to do for that? Now see here, when you add a new node, r is the new variable that is going to create a new node. R is equal to new node. R of data is equal to number. Whatever number you have to initialize, that number is passed as a parameter to the data. R of link is equal to null, because since it is the last node that is being added, the link part should be initialized with null and temp of link should be initialized with R. Means the address of R, now here this will be our node R. The address of this R will be stored here. So if suppose this is 300 will be stored in the address part of this, that is temp of link will become 300 and temp of link will be null here. That means temp of link will be null because this is the last node now in the present situation. Clear? So this is how you are going to append to the already existing list. Alright, so here when you are appending, you have to remember that the nodes that are already present will be existing and you will add the newly added link to the already existing last node. Right, now after the appending, what I have to do? See, I have appended 5 elements. That means if there are any nodes, it will be added to that nodes. Otherwise, new node will be created and 5 elements are being added to the nodes. After this, what I have to do? The elements in the linked list, l.display. You have to use the display function to display the elements that are present in the linked list. So what will display function do? Let us go to the display function and see what is happening. Now here is a display function. So displays the contents of the linked list. Void linked list display node star temp is equal to P. What is star temp here? Star temp is a pointer which stores the address of P. What is address of P? It is null. So what you have to do? If it is null, you have to come out and print cout endl. Now here traverse the entire linked list while temp not is equal to null. That means until and unless you reach to the last node, you have to execute the statements that are present inside this particular while loop. What are the statements present here? Cout temp of data. Whatever data is being present at that particular node, data part, you have to print that data and move to the next link, because whatever elements are present, you have to move to the next link. Now suppose, for example, if I am taking this, now here when temp is not equal to null, it will be in the first position, so it will print 10 first. Then temp is equal to temp of link. Link means 100, so it will move to the next node. This is 100, isn't it? So when it moves to the next node, the data part present here is 20. It will print 20. Then temp is equal to temp of link. It will move to next. The address of next is 30. That is 300. So it will print 30. Then it will move to the next element. That is 40. Now this will get executed until and unless the temp is not equal to null. Once you reach this particular statement, what happens? You will come out of the while loop. Now once you come out of the while loop, there will be no other elements that are to be displayed. So you will come out of the complete function of the display itself. Okay, so here what you are doing, you are adding the elements and you are displaying the elements after the use of append function. Okay, so we have appended 5 elements and we have displayed those elements. Now we are calling a function L.add at the beginning. Means you have some elements already existing in the list, and for that you have to add a new element at the beginning only. That means to the list already existed, you have to add a new element. So we'll just see how you are going to add a new element at the beginning. Now here is the program for that. Here is the code for that. Now actually this is very easy, because you have to just create a node and add the address of the first node to the new node, isn't it? So here we are seeing this void linked list add at the beginning int number. Number is the data that you have to add. Node start temp, which adds a new node. So temp is equal to new node. So here new is the operator that we are using for creating the memory to the node that you have to create now. Okay, so temp of data is equal to number. The number that you are passing from number will get saved into this data part. Temp of link is equal to p. Okay, so p is equal to temp. So what will happen here? We are creating a node called r here. R contains an element called 999, and the new node should have the address of the next node. Now suppose the address of this first node is 1000. So 1000 will be placed here and it will be pointed to the first node. So what you are doing here? Temp of link is equal to p and p is equal to temp. So you are building a connection between the first node that you have created and the next node that is already in the first position. Okay, so with this what happens? The first node's address will be stored with p, and p contains the new node's address, that is temp. So a connection is established between the two nodes, that is the new node and the first node. So like this I am inserting 3 elements. Add at the beginning. I am inserting 999, I am inserting 888 and I am inserting 777. So how many elements are being completed now? You have 5 elements that we have added through append function. We have 3 elements that we have added through the add at the beginning function. Now after the add at the beginning function, I am again displaying cout statement, the elements in the list after adding at the beginning, and you are using the display function. So same procedure again for the display also. Whatever elements are present in the list, all the elements will be traversed from the 0th position to the next position, and it will go on printing all the elements by traversing to the next element, next node with the help of the addresses. Okay, so the display of the elements will be performed. Now L.add after. Add after 7, 0 means after the 7th position, after the 7th node, I want to add an element, and that name of the element is 0. Okay, and next is L.add after 2, 1. After the position 2, I have to add an element called 1, and after the position 5, I have to add an element called 99. So we'll just get into the program of the add after. So here is the program of add after. Now here the location that you want to print to move will be produced here, and the number is a parameter, the data of the number that you're passing. Then node star temp and star r. Now again here we are creating a new node because we have to add after a particular position. Now first temp is equal to P means you have to move to the desired location. So when you have to move to the desired location, once the P value is initialized with the temp variable, then you can move or traverse to the desired location. For int I is equal to 0, I less than location, I plus plus. Now what is I value here? I value is 0. Okay, so I is 0, I less than location. I is 0 and less than location. What is the location we have passed here? Maybe for example 7. I have just shown you the elements that are added. So 7 is there, 9 is there and 5 is there. We'll just take an example of 7. So 0 is less than 7. So the location that you want to add after this particular location 7. So 7 is less than greater than 0 is less than 7, and you will enter into this particular statement. Temp is equal to temp of link. So you are traversing and incrementing the value of I, and you will reach to this particular position. So I should be 7. Go on incrementing. Then 7 is less than 7, the condition goes false. When 7 is less than 7, condition goes false, immediately it will shift to the next statement. Now what is happening in the next statement? If end of linked list is encountered, that means if the location that you have sent is after the null, that means if 7 is not encountered, and if temp value reaches null, then you have to display the number that you want is not present in the list, because the location that you have specified is less than the number of elements present in the list, and you will return the value. If suppose that is not the case, that means if temp is not reaching null, then you have to insert a new node after the position 7. Okay, so here you are coming out of the for loop, checking if temp is equal to null. If temp is equal to null, you will execute these statements. Otherwise, you will go to the next part. That is, here you have to create a new node. That is, R is equal to new node. So R is the new node that you are going to create each and every time that you want to create a node. So R will be created with a new node. Then R of data will be initialized with a number that you want. R of link will be the temp of link, and temp of link will be R. So what is happening here? I'll just show you how diagrammatically. Now here these are the elements that are already added. Now suppose if I want to add a node after the third position. Now here 1, 2, 3 third position node is there. Then you have the fourth node is there. Okay, so what I am doing here is I am adding a new node at this particular position. So when I add the new node here, what should happen? I am adding an element called 50 here, and then the value that I want to add here is null. Automatically when you create a node, it will be with 50 the data and the link. So what you have to do, this 300 should point to this particular node, and this node should point to this particular node. So what is happening? After 3, it should be linked to the new node, that is the address of the new node is 500. So here instead of 300, you will have 500. So it will have a connectivity to the new node. Then here instead of null, you will have a connectivity to 300. So that means you will have a connectivity towards the node with address 300. So you got a connection wherein you have added an element called 50 after the location 3. Okay, so this is how you are going to add after a particular location. Got this? So this is how you are going to add it. So here we are making the links to the new node with the old node and to the next node. So R of link is equal to temp of link, and temp of link is equal to R. So making a connectivity between the previous node to the new node and the next node to the new node. So this is how the connection is being built. And next, after the adding is completed, here see, here we have added 3 more nodes again. So 5 nodes here, 3 nodes here, and 3 more nodes here. Now elements in the linked list, after adding at the given position, you are displaying the elements. Okay, now after you display the elements after adding, you have to count the number of elements present in the linked list. So see out number of elements in linked list L dot count. When you call this particular count function, it should take me to the count function. So what is count function here? Now here linked list count, and int is the type of data type that you are going to use, because we are returning the value of that particular variable outside this function. So we have to use the data type of the return type that you are using for the variable. So since it is integer, we are using int linked list count. So node star temp is equal to p. So whatever p value is there will be initialized with the temp variable. Int c is equal to 0. So we are initializing c value with 0. Now traverse the entire linked list and count the number of elements or nodes that are present in the list. While temp is not equal to null, that means you should go on executing until and unless the temp value reaches null. Okay, so until and unless temp value is equal to null, temp is equal to temp of link. That means you will go on moving from one position to the other position, from one node to the other node. And when you are moving to the next node, you are counting the C value, because the C value is the number of elements, the data parts that are present in the links. So as soon as you move from temp is equal to temp of link, you will go on incrementing the C++ value. So initially C will be 0, and each time you move, C will be incremented by one value, and when it reaches to temp is equal to null, the counting gets stopped. So once the counting gets stopped, the value of C will be stored in the C variable, and that C value you are returning to the calling function, that is to the main function. So here when you get L dot count here, you will get the total number of elements that are present in this particular list. Okay, so it will print number of elements in the linked list are so many values. Whatever number of values you get, that value will be displayed there. Then coming to the delete function. So when you are using the delete function, I am trying to delete 3 elements here. So when you say L dot delete, it will automatically move to the delete function. So what is delete function doing here? So here is a delete function. It deletes a specified node from the linked list. And one more important thing that you have to remember here is, unlike arrays, here you are not going to delete and put 0. You have to delete the complete node. As I have already said, when you create a new node with a new operator, you have to delete the element with the delete operator. You have to delete the constructor that is being constructed through the class object. Okay, a destructor is to be used to destruct the memory that is being allocated through the constructor. So first we will see how the node is being deleted. Whatever number you want to delete, you will just pass that number as a parameter to the delete function. Node star old star temp. Temp is equal to p. What is star old here? Because once you delete an element, you have to reconnect the elements with the nodes, the old node and the next node, when you delete the node from the middle. Okay, so while temp is not equal to null, you will move temp of data is equal to number. If temp is equal to null, you can't delete an element. So always see that the temp is not equal to null. If temp of data is equal to number that you have passed as a parameter from the number, then you can delete that node. Node to be deleted is the first element. So what you have to do, temp is equal to p is equal to temp of link. Okay, so if the first node is to be deleted, then there will be no nodes. So you have to first check if it is null, then you have to move to the next list. Then if you want to delete the intermediate nodes in the linked list, if suppose we want to delete an intermediate linked list, then you will move to the else part. Now here remember that the if part will not get executed, because since it is the first node and only node that is present, you can't delete this. So this if part will not execute and it will enter into the else part here. So in the else part, what is happening? Old of link is equal to temp of link. Free the memory occupied by the node using the delete operator. Delete temp. So when you delete the temp, the link will be deleted, and the link, when link gets deleted, automatically the node gets deleted. So what you have to do, traverse the linked list till the last node is reached and then point to the new node. Else the old points to the previous node, old is equal to temp, and go to the next node, temp is equal to temp of link. Okay, see out the element that is deleted is the number, and whatever element is deleted, that number will be deleted, and if it is not found, then you will say element is not found. So I am just showing you diagrammatically here. Now here we have added this particular element 50. Okay, so what I want is, I want to delete this particular 50th element only. So what I have to do, when you delete this element, this connections whatever you have given should be removed. So what you have to do, you will use delete the operator, the delete number will be used and delete link will be used. So when you are using delete link, automatically this link will be deleted. So this link will be cut and this link will be cut. So you have to remove this particular node. When you have to remove this particular node, what I have to do? Now this becomes the old node and this becomes the next node. So what you have to do, this new address should be removed, that is 500 is to be removed, and 300 is that is the next node's address will be placed, and a connectivity will be built between these two. So now here 300 will be added, that is the next node's address. So that is what is being done here. When old is equal to temp, go to the temp is equal to temp of link, that is the next node's address will be printed. If suppose this is not performed, then you will say the element that you are searching is not found, the element that you want to delete is not found, then you will come out of the loop. After this, what happens? The number of elements that you want to delete will get deleted. You are using delete function 3 times, so you are deleting it for 3 times. Then the elements on the linked list, after deletion, you have to use a display function to display the total number of elements that are deleted. After that, you have to count by using the count function. Now before this, I just wanted to explain you the destructor. To deallocate the memory, you have to use a destructor. So whatever node is being created by using the constructor, that is p is equal to null in the starting, that you have to delete. So what you are doing here, while p not equal to null, since if it is not the first node, you can move to the next link, whatever you want to delete. Q is equal to p of link and delete the p. So when p is equal to null, now p will be initialized with the q value. Now if p is equal to null, then you can't do this because it will be the only node and you can't deallocate the memory, you can't delete that particular memory. So here, once q is initialized with the next node, you will traverse through the next node and see whatever link is being getting deleted, and that you are initializing it with the p value. So p will be equal to q value. So this is how the linked list gets performed. So you have to concentrate on how you are linking the elements, how you are linking the elements through the addresses, how you are linking the elements through the data members, and how you are moving from the temporary variable to the p and to the link part. Okay, so here always